they are true, so you just need to remember them. And those three are really easy to mix them together, and it's really hard to make, really easy to make mistakes. So we're talking about two chords, or the tangent and the chords in the circle, and we talk about the relationship between them. So for the first one, we have when two chords intersect as shown. Okay, so you have two chords in the circle, and there's an intersection here. Okay, they intersect inside, and the two chords are both inside. And then it cut at the point P here. Then you have AP times CP equals to BP times DP. Okay, so it cut into 4 pieces. So this part times the rest of itself will equals to this one times what has been left for itself. Okay, so it's itself times itself equals to the other one times itself. Okay, so you times them together, but you times the same numbers here. Okay, times same numbers here. I can, yeah.
How do you know, like, when it says AC equals BD, how do you know they're talking about, like, A times C and not A to C, like the line?
Wait, which one? You
know how it says, just in the explanation, it says AC equals BD?
AC equals BD, yeah.
How do you know that it's like A times C and not A to C?
A to C, when you talk about A to C, they will have like a line segment. Like there's this very previous years, like in year 7, if you talk about line segment, you have a hat on the top, like you have said that is that. But like normally what we say will be times like what we have learned so far, unless it's that the line segment AC equals to the line segment BD. And also we are not using lowercase letters to talk about like A to C. We use like capital AC to represent the length. We very few of the time we'll use lowercase to talk about A and C. Yeah. So that's the first one, and then the second one will be like the first one is they intersect inside. Okay, so intersect inside the circle. So you have another one will be intersect outside the circle. So you have this one, like these two are the chords in the circle, but they cannot intersect in the circle. So we extend this chord and to make it intersect outside at the point P. Okay, intersects outside at the point P. Then you have AP times BP. Okay, so AP is still itself times itself, but not like the separate part. It will be what has been the actual one times the whole length. And equals to DB times CP will be here times the whole part for itself. It's the outside one times the entire one. Okay, the outside bit times the entire bit equals to the other one's outside bit times the entire bit. Okay, so that's the difference between the first one and the second one. One is intersects inside and the other one is intersects outside. Okay, and the next one is when a second intersects a tangent, then the external point is shown below. So this is the tangent. Okay, so PC is the tangent and the contact point is the point C here. And then you will have BP here. Okay, BA is the line segment, but you extend that and to meet the tangent and at a point P. Then that will equals to AP times BP. So still the outside bit times the entire bit. And then equals to CP times itself. Okay, equals to CP times itself. Because I don't have the entire bit, I don't have the inside bit. The outside bit is CP and the entire bit is still CP. So it's CP times CP. You can remember in that way. It's always the outside bit times the entire bit. But for CP, outside bit is CP and the entire bit is still CP. So it's CP squared. Okay, so it's always like you never times this line and the other line. You always time the same line. Okay, the line segment on the same line. And if you have outside bit, it's always the outside bit times the whole bit And if it's all inside, then will be one part times the other part equals to one part times the other part. Okay, so that's the 3 rules. Okay, that's the 3 rules. So let's have a think those questions. So for example 1, it intersects inside. Okay, it intersects inside. So itself times itself. So it's 1 times 5 equals to 3x. Then x must be 5 over 3. There's no like complex questions. It's quite obvious. Okay, so you just use that to apply this. And for the next one is intersects outside. Okay, intersects outside. So this part is 19. Okay, this part is 19 and this part is x. Okay, inside bit is 19 and inside bit is x. So it intersects outside. So it's the outside bit times the entire thing equals to the outside bit times the entire thing. Okay, so it's the whole thing. You need to add them. You need to add them. And then you have 9 times 28 equals to 8. Let's say that's divide by 8 equals to 8 plus x. So you have divide this by 4, you have 2, divide this by 4, you have 7. So minus 8. So x will equals to that. 8 is 16 on 2. Then x will be that. Okay, 47 on 2. So 28 times 9 divide by 8 by 4, 2, 7, 64. Calculations. So have meters. 47 over 2 meters. It's not hard. The important thing is just remember the rule and you can put the rule into the correct notation. Okay, put the rule into the correct choose one of the correct rules. Okay, so for the next one, which one? It's the outside bit times the entire bit. Because the whole bit is 9 plus 19, the 19 is only the inside bit. No, 9 is this.
Okay, sorry, I'm looking at the wrong thing.
Okay. 9 is here, 8 is here, and 19 is the blue, and x is the blue part. Any questions? No? And the third one is the tangent intersects with the chord outside. Okay, outside. If still outside, you use the outside bit times the whole thing equals to 7 times 7. Because 7 is outside and also the entire thing. So 7 times 7. So 5 plus x equals to 49 over 5. X equals to 49 over 5. Subtract 25 over 5. So it's 24 over 5. I just want to ask, like, have a guess where those rules coming from. Like, when we prove all of the previous thing, we all use congruent triangles, right? We all use congruent triangles to say, oh, that equals to that, that perpendicular to that. So for those 3 rules, what do you think that which method we should use to prove? We cannot prove congruent because congruent not apply to something times something equals to another times another. I'll give you a hint. So say for the first one, you have AP times AP times CP equals to that times that. Let's say I can make that AP divided by BP equals to DP divided by CP. If I write that into this form, what do you think? Does that give you a hint? Is that factor? Yeah, when we talk about scale factors, that's a triangle. You have two lengths. So we use similar triangles. It's scale factors, but we use similar triangles to prove those three. So if in the first diagram you can connect AD and you can connect BC, can you see this angle and this angle will be the same because they all subtended by the same arc here. Okay, those two angles must be the same. They all subtended by the same arc. And this angle and this angle must be the same because they all subtended by this arc. And also we will have vertical opposite angles, they must be equal. So three angles equal by AAA, you can say they are similar triangles. Okay, triangle ADP is similar to triangle A is corresponding to B, so I have B. D is corresponding to C, so it's BCP. Okay, those triangles must be the same. Similar triangles. And then when you talk about the ratios, let's say AP, so opposite to the right angle, over BP, that must gives you like the black one is DP and the black one opposite to PC. And if you can cross multiply them, so you will have AP times PC equals to BP times DP. And I have proved that. It's because of similar triangles. Okay, it's because of similar triangles. It would be good if you know this, like you know where your rule comes from, and if you forget, you can still prove on that, like in the exam. Okay, it's good to know this method, but I'm not forcing you to must remember that. But it's like something you really need to know, okay, and you really need to think about. So that's the first one. And if you can think about the second one, I will help you to connect them. Let's say we connect BD. And let's connect AC. Okay, let's connect BD and AC. Let's think about the triangle APC. APC, this one. And let's think about BDP. Okay, we think about those two triangles. Okay, we have this must be equals to this because they're all subtended by this arc. Okay, those two triangles must be, those two angles must be the same. And also they share a same angle here. They all have the angle P here, so they share that angle. So therefore, you have two pair of angles already equals to each other. Okay, you have two pair of angles equals to each other. Then the third pair must be the same. So where's the third pair? That's this one. And and also this one. Okay, those two angles are the same. Those two angles are the same. So if I can write triangle APC is similar to the triangle, okay, APC, right? I'll start from this A, so D will be the corresponding point, and P will still be that point, and C will give you corresponding point at B. So it's DBP. Okay, so if I can put that triangle in blue, okay, we're looking for this triangle, that's triangle in blue, and I put another one in pink. That one is in pink. Okay, I'm looking for those two triangles. And I will start to write. Okay. I'll start from the blue triangle. Okay, I'll start from the blue triangle. So I will try BP. Okay, let's try BP. BP is opposite to this angle. So the corresponding angle is here. So it's PC equals to. Okay, I have finished this one. I'll go for this one. So it's DP. So DP is opposite to this green angle. Then AP is opposite to the green angle as well. So you have cross multiplication. AP equals to BP. AP times BP equals to DP times CP. Okay, DP times CP. So that's by similar triangles as well. And similarly, if you're trying to do this one, I think it's connecting this and connecting this. But this one will be much harder to talk about. They will be much harder to talk about. So I may not go through this one with you. So you can have a think about this one. If I can put that into the ratio form, AP and CP. So that can be AP over CP equals to CP over BP. Okay, so AP and CP is one and BP and CP is another one. So actually I'm looking for this triangle and also for this triangle here. Okay, for this one and this one. If you can see this one, this is really good because do you remember the alternate rules? Like you have a tangent here and you have a chord here. The angle make is here. Okay, this is the angle you make, and then the opposite angle in the circle will be the same by the alternate theorems, like what you learn in the end. So that two angle must be the same. And then you have this angle. You have this angle equals to itself. So this blue angle is in both triangles. So the triangle APC will be similar to the triangle. Okay, so you start from A. So it's this one. C and P is still P and C is B. So they are similar. APC similar to triangle CPB. Okay, so we have AC over, okay, AC is this blue angle and over this BC and equals to, let's say the big one is opposite to PC and this big one is opposite to BP. PC here. Okay, AC. That's AP over PC. So you have AP times BP equals to PC squared. Like it's similar. Yeah. Same ratio. Yes, like the scale factor. If you like it's hard to see these triangles in. Yeah, because but what I can do is I can separate that. Okay, that's P, that's C, and that's B. And with the B, I have a green angle, and with that P, I will have a blue angle. And then the other triangle will be this. So it's P, A, C. Then with the C, I have a green one. With the P, I have a blue one. Then it's easier to see in these two triangles. Yeah, because you have three angles all equal, because of AA, those two are similar. I'm not writing a full proof here, but like those two are similar, and then you using the scale length. For example, AP over PC. So AP is here and PC is here. They are corresponding pairs. So that over that equals to PC over BP. So PC is here, BP is here. They are corresponding pairs using this. Okay. So if you can't see those two triangles, separate them out and try to see the corresponding pairs. I understand it's quite hard to find the corresponding pairs. So separate as two triangles and then write it down. Okay, and I remember there's one more question I haven't gone through with you from the previous page. This one. In this, I'm not sure if you have think about this question or not, but like this is actually a hard question. Like you can do it and you can give me the right answer. Okay, I'm not like thought about this. You can give me right answers, but you may not give me enough proof. Okay, you may not give me enough proof for this question. Let's think about first. We have AD is 5 and DB is 12, and I'm looking for AB. I think AB. I'm looking for AB. That's not S. I'm looking for AB. So if I'm looking for the length of AB, so first of all, what's the relationship between AB and CD? What's the relationship between AB and CD? CD is 8. Okay, there's another information. CD is 8. So AB, if you see on the graph, you may tell me like CD is perpendicular bisects of that line. Okay, perpendicular bisects of that line. I can see it, but can I directly use it? I can't, because there's no such rules to telling me that's the rule and you can use it. Okay, there's no rules for like two circles overlap and what will happen. So you need to prove that AD and AB and CD are perpendicular bisector. Like you need to prove on that. You need to say, let's say we intersect at point P here. You need to say CP equals to DP, and also AB is perpendicular to CD. So you need to find a way to prove this. If like, let's think about if you can prove ACP and ADP are congruent triangles. This can be easily proved, right? If you can prove ACP, ACP, and ADP, they are congruent triangles, then you can easily prove on this. But like the problem is I can't. Okay, I can't find enough information for me to say they are congruent, because the information I know for those two triangles, AC equals to AD, because that's the radius, and AP and AP are the same common length. But I don't have any other information except that. I don't know angles. I don't know CP. So maybe if I can say those two angles are equal, then I can prove they're congruent and all the things can be solved. But let's think about two triangles first, ACB and ADB. Think about those two triangles, ACB and ADB. So AC equals to AD, because that's the common length. And also BC equals to BD. That's not common, that's the radius. And also for that, okay, it's radius as well. And also we will have AB equals to AB. That's the common one. Okay, that's the common one. what you can say is triangle ABC is congruent to the triangle ABD. Can you see that? Because 3 lines lengths all equal, that's SSS. Okay, to the 2 big triangles, they are congruent. Why I want to know that's congruent triangles? Because I want to know the information. So CAP must be equals to the angle DAP. Okay, so those two, those two angles must be equal. Okay, those two angles must be equal because they are congruent triangles. So those two angles must be equal to each other. Okay, because those two angles are equal, that 2 big triangles are congruent triangles, and I know the corresponding angle must be the same. Now I want to say also AC equals to AD, that's the radius, like we repeat again from the top, and AP equals to AP. That is, what's that? That is common. Okay, so I say AC equals to AD. And also the common one, and you have the angle included equal because of those 2 big triangles equal. So triangle ACP must be equals to the triangle ADP by SAS. Okay, you have 2 sides and 1 angle, included angle. So you have those 2 small triangles equal. I'll just take off all the thing I know. So what do you know now? So CP must be equals to DP, and they must equals to half of CD, which is 4. Okay, because giving you the length of CD is 8, so they are half and half. Okay, because it's congruent, so those 2 pairs must be the same. And then you have half half, so it's 4 and 4. You have CP equals to DP equals to 4. And also the angle APC equals to the angle APD. Okay, the corresponding angles, those 2 must be equal. Also APC plus APD equals to 180 degrees. So therefore APC equals to APD equals to 90 degrees. Okay, because they are equal and they add up to 180, so half of them must be 90 degrees. So now I can say CP, so AB perpendicular to CD. Okay, so AB perpendicular to CD. Those 2 lines are perpendicular to each other. Then you have 4 right angle triangle. Okay, you have 4 right angle triangle. So in right angle triangle APD, okay, in the right angle triangle APD, you have the information of AD equals to 5, BD equals to 12. 5 and 12. And also you know that is 4. Okay, no, that is 4. So AP will equals to square root of AD squared subtract PD squared. Okay, the hypotenuse, subtract the side and the square root everything. That will give you AP. So AD equals to 5. 5 squared subtract 4 squared. That equals to 3. Okay, 3, 4, 5. That equals to 3. Say in right angle triangle BDP. Okay, you have BDP, the right hand side one. BP will equals to square root of BD squared subtract PD squared. That gives me 12 squared minus 4 squared equals to 144 subtract 16. That's an 8. That's 1 to 8. So square root 1 to 8. And 1 to 8 can divide by 4. You have 32. Divide by 4. You have 8. Divide by 4. You have 2. Is that correct? So I have 4 can be 2 times 2. I have 3 2's. So it's 8 square root 2. 8 square root 2. 64 times 2 is 1 to 8. So it's 8 square root 2. So what is AB? AB equals to AP plus PB. And that equals to 3 plus 8 square root 2. That equals to 8 square root 2. I think like a lot of you can give me correct answer, but like you only write the right hand side part. So you totally ignore, like you assume that it's perpendicular and you assume that is bisects the length, but you don't know why it's really bisects. So all this part here is ready, like to make you ready to use this information. So you need to prove all of that.